and calculate, hit enter. So it says chi-square test statistics 16.20. That's the same number that we got right here. (16.20). And the p-value, 3.0 times 10 to the negative 4. I don't think we calculated the p-value. We could. We set it up. We just never stuck it in the calculator. Let's do that right now to make sure that we get 0.0003, which is what the calculator spat out. Let's do it. Second distribution, chi-square CDF, 16.2, comma, 100, degrees of freedom 2. 3.0 times 10 to the negative 4. That's exactly what it gave us. So we're good. And obviously p is less than alpha, so reject H naught. Are you with me? Chi-square CDF for p-value, yeah. Let's do another one. Page 10. A medical researcher tests 640 heart attack victims for the presence of a certain antibody in their blood and cross-classifies against the severity of the attack. The results are reported below. So I have a matrix 2 by 3. 2 by 3 matrix. That means that this test will be done at 2 degrees of freedom. R minus 1 times C minus 1, I'm here, right? R minus 1 times C minus 1 degrees of freedom, which is 2. So I can do 1 or 2 of these cells by hand, and then I'm going to stick it in my calculator because it's a waste of time. But let's say I was looking for this cell right here. This cell, 1, 1. I'm trying to find where did this cell come from. So I'm going to take its row total, 360, divided by the grand total, 640, and multiply by the column total, 125. Under independence, this is the result that I'm expecting. So 360 divided by 640 times 125. 70.31. That's where that number came from. Follow? Okay. Similarly, this number would be 280 divided by 640. That's the row total divided by the grand total times the column total. So let's see, 280 divided by 640 times 295. 129.06. But truly, you're not going to be doing these by hand. You're going to go put them in your calculator. So let's do that right now. Second matrix, edit, it's 2 by 3 again, so I'll leave that alone, 2 by 3, and hit enter. And it's just going to rewrite over the existing matrix. So the first one would be 85, 125, 150, 40, 95, 145. stat test chi-square test. Observed A, sure. Expected B, sure. Just keep hitting enter. Calculate. The chi-square test statistic is 10.54. When I did this by hand, I got 10.55. And the p-value was 0.005. Well, calculator did the whole thing for you. And interestingly enough, if you go to stat, go to second matrix, edit B, it'll give you the whole expectation matrix. Second matrix, edit B. Here's my expectation matrix. Look, 70.31, 123.75, and so forth. So if I said to you, what is the contribution to the chi-square test statistic from cell 2, 2? You can expect a problem like that on your test. So regarding page 10, what is the contribution to the test statistic from medium and negative antibody? Negative antibody and medium cell. So it's saying, I want the contribution to this chi-naught squared equals observed minus expected squared over expected. I want the number just from that cell. So here's medium and negative, right here and right here. So the answer to this would be 95 minus 96.25 square over 96.25. Does that make sense to you? So I would have 6 of these, one for the first cell, one for the next cell, and so forth. I'm only asking you to do it for this cell right here, medium and negative antibody. So 95 minus 96.25, square it, divided by 96.25, and that gives me what? 95, oops, let's clear this. 95 minus 96.25, square it, and divide by 96.25. I get 0.016. This is one of the 6 pieces up the chi-naught squared test statistic. Get it? Do you have any questions regarding this one? Yeah.
So is there something that's called, like a definition for the 0.06, 0.016?
No, it's going to say what is the contribution to the test statistic from this particular cell. Yeah.
Okay.
So what is the contribution to the test statistic from this particular cell, negative and medium?
Okay.
Right? So cell 2, 2, 2. Second row, second column. Got it? Okay, so that's the test of independence, i.e. no association. And the next test, very similar, just 2 pages down, go to page 12. It's the chi-square test for homogeneity of proportions. But this time, it's from two populations or more, and therefore 2 or more samples. So every other test so far was on one sample from one population. And it's not the case now. Now I have P populations. And I'm taking samples from these P populations. So in this case, your null hypothesis and your alternate hypothesis would look like this. The proportions are the same versus the proportions are not the same. Proportions of what? What are we talking about here? Let me give you an example. Let's say that I have 2 drugs. So chi-square test for homogeneity of proportions. Let's say that I have 2 drugs, drug 1 and drug 2. So for example, Allegra and Zyrtec. And I want to see about insomnia. Insomnia, no insomnia. So I want to see if the proportion of insomniacs are the same for drug 1 and drug 2 and drug 3. That's why it says C populations. Add another drug, why don't you? It doesn't matter. Drug 3. So let's say Claritin D. And I'm interested in seeing if the proportion who experience insomnia are the same for all 3 drugs. So I would say H naught, P1 equals P2 equals P3 versus HA, at least one has a different probability from the rest. And this test is also done on an R by C matrix. So all these 6 numbers would be provided to you for observed counts. Again, R by C matrix. Again, R minus 1 by C minus 1 degrees of freedom. And again, chi-square test. Chi-squared. R minus 1 times C minus 1 degrees of freedom. It's done exactly the same way. You already know how to do this. You stick it in your calculator, in other words. We create an expected table and we do this again. Chi naught squared equals summation over all rows and columns of observed minus expected squared over expected. And you're not going to do this by hand, you're going to let the calculator do it. And you can find your expected matrix exactly the same way as we did before, because here you want the probability of insomnia, which is the insomnia total over the grand total times the column total. So the formula remains the same. This divided by this times that to find the expected cell for this count. You follow me? So just as we were doing before, let me put some numbers in here just for kicks, right? Let's say that this column total is 20, and let's say that this is Allegra, so let's say 3 and 17. And for Zyrtec, let's say 15 and 5 and 20. These all don't have to be 20 though. I can make this 40. Claritin D is 3 and 37 out of 40 because